What's going on, everyone? This is Dustin with Electrician U, and today Diablo sent me some blades. So they wanted me to do some, I guess, reviews or kind of showcase what kind of blades they've got for metal cutting. So, Christmas time. Inside, this pack actually has some wood stuff. I'm not going to do wood today. I'll talk about that later. But I'm going to do these three metal cutting blades. There's one that's for thin metal. It's carbide. Medium metal and thick metal, they're both carbide as well. So all three of these are carbide, but I am also going to talk about bimetal as well, and the reasons why bimetal is still a viable option for electricians. All right, so first up on our list is the thin metal carbide. This specifically says on it, it is for cast iron, high strength alloys, and stainless steel. It's not meant for just light gauge steel and aluminum, which I made the mistake of cutting and then breaking these and figuring out, like, why is it doing this? And I'll talk a little bit more about that later. But this is a 6-inch blade. It's got 20 teeth per inch. It's meant to cut anything that's less than an 1/8 inch thick. So you got to really pay attention when you read these as to what they're designed for. Otherwise, they're not going to cut like you want them to. So for this, you'll notice this is a carbide blade, but it has regular teeth like a normal Sawzall blade would, like a bimetal. This is a bimetal, and this is the carbide. So with a bimetal blade, the entire blade is one piece of metal, and they just notch the teeth into it for it to cut. With carbide on this thin metal, the only way they could get those small teeth like that is by creating an entire blade and an entire carbide like tooth out that is separate. So the teeth are made of one solid strip of carbide, and then they just take that whole strip and attach it to the blade itself. Whereas again, this thing, they're just cutting the teeth into the blade. And we'll get more into the other ones, but like the carbide on like the medium and thick metal, each tooth is added to the blade, one individual tooth at a time. So this is the thin metal 20 TPI carbide blade. All right, so you see how that cuts through like butter. This blade is meant for that thin metal. It's got a whole lot of teeth, so it's not going to jump around too much. But let me go over to the medium metal, and I'll show you what the difference is. Next up is the medium metal carbide. This is a 9-inch blade. It's got 10 teeth per inch. Again, each tooth itself is made out of 2 different metals. It's an alloy, so it's a carbide, and then they tack each one of the teeth on one at a time in a machining process. This is specifically for anything that is 1/16 to 5/16 thick. So you don't want to cut stuff that's too thin, but you also don't want to cut stuff that's too thick. It's meant for all metals. It said strut, pipe, cast iron, and stainless steel. So this should cut really anything, thin or thick, as long as you're within 1/16 to 5/16. But also densities of metal too. Like stainless steel is really difficult to cut through. It's just really thick, dense steel. So let's see how this guy cuts. Like butter. So let's go to something slightly thicker, a little bit closer to an 1/8 inch. Not really. I mean, in all honesty, this strut's about the same thickness as this EMT. Let's see if I can get this close to you. So they look like they're about the same thickness. The strut's a little bit thicker. Not quite 1/8 of an inch, but because it's, when I cut it, I'm going to cut on the front side of it. I'm going to call it an 1/8 inch because I'm adding material to the cut. I'm actually cutting in 2 places at one time. All right, so again, this is the medium metal blade. Like butter. So a lot of people are going to comment, why aren't you just using a bandsaw? Because I'm doing a tool review on not a bandsaw, that's why. But I would probably use a bandsaw when I'm cutting anything like this. I just want to show the versatility of it, really. If you have these, you can cut through pretty much anything that you're going to deal with. You just don't want to use it on really thin stuff like that sheet metal that we were just talking about. So that's really for like medium. You're talking 1/16 to 1/8 inch. You're probably okay cutting like purlins if you had to like, you know, cut building steel or something like that. Not the thick actual like I-beams, but the thin purlins you could cut easily with the medium metal blade. So now let's move over to the thick metal. All right, last up is the thick metal carbide blade. This one is 8 teeth per inch, so pretty close to the medium as far as like rigidity and everything. The tooth count is just a little bit different. There's less teeth. You need to, when you're cutting thicker materials, you need to allow more heat to escape. Any kind of heat buildup or vibration is going to cause any blade to just go to shit. So less teeth means more air in between each teeth. This says that it will do thick metal 3/16 to 9/16. So that's just over a 1/2 inch thick metal. Like you could cut beams and stuff with this. It's specifically for cast iron, high strength alloys, and stainless steel. So just like the thin metal, funny enough, the same materials, both of these are designed to cut. Just one of them is for thicker of those kind of materials and one is for thin. So let's see how the thick metal cuts. Got some rigid conduit. So I'm gonna go with that because rigid is about 5/32 thick, which is close to 3/8. Thick metal will go all the way up to 9/16. Let me see. 8 teeth per inch. It'll go 3/16 to 9/16. So again, you don't want to cut anything really thin with this, or it's just going to gnarl it all up. 9/16 is over a 1/2 inch thick though. Like I wish that I had a beam around that I could just try to cut through a beam with. But this rigid conduit is very, very stout stuff. Most of you electricians know that cutting this stuff really sucks. So let's see how the thick metal blade does on it. That does a really good job. I don't have any missing teeth, so it's still intact, but it does a really good job. That with a bimetal blade I would still be cutting if I was cutting with something that was bimetal or like a thin metal blade, and it would probably chew that blade up immediately. So the thick metal blade, those will last you quite a few cuts when you're cutting thick stuff like this. This is like a $15 lock, and it's a boron carbide lock. So this thing is supposed to be extremely hard to cut. I think it's rated on a 1 out of 10. It's rated a 10. Let's see. I need to get a good grip on it. So. Alright, let's see how this baby cuts. This is carbide cutting carbide. I'm trying to move it back and forth so it's not staying on the same spot and overheating the teeth. That's some hard ass steel to get through. And I've got all my teeth intact. Yeah, I've had blades in the past where the teeth have come off after doing like one of those cuts. So this has made it through several different things. You can see up close, the teeth are all still intact. Normally what'll happen is like one of them will go missing or it'll start to misshape. Let's see if you can find any. I don't see any that are damaged. They all look like they're still in pretty good shape. So I'm impressed with that. That thing will cut a lot. But the one smart thing to do is either cut with oil. I mean, these blades are expensive. These are probably like $15 per blade, whereas like bimetal stuff, you could probably get 5 blades for $15. So these blades, you see me abusing them because I get them sent to me, so it doesn't really matter. But if I were out in the field with these, I'd be really careful. I would not overheat them. I would cut for a little while. If you start to notice the sparking and the heat building up, just stop, back off for a minute, pour some oil on it, start cutting again. But you really want to take care of blades. Another thing, like unibits and stuff that you use, same thing. Don't overheat them. Don't run them on high. You know, like start them off at a low speed and then start speeding up, maybe move the blade around a little bit. It's just taking care of your blade. It's not that Diablo says you have to do that or else our blades are gonna break. It's what I say that you should do because it's just taking care of an expensive tool that you've got. All right, the last thing that I wanna talk about is bimetal versus carbide. So I touched on this a little bit. The teeth are pretty similar in what they're used for. Bimetal is still a viable option. A lot of the companies that are making blades right now are really trying to push the carbide thing. Use carbide, use carbide. And it's because the teeth last longer and it looks more impressive when you have a video camera shooting somebody cutting something. You're supposed to be able to get about 50 cuts on a carbide to 1 cut on a bimetal blade. But what I've found is if you don't look at what each one of these things says, it's for cast iron, high strength alloys, stainless steel, and for a certain thickness. If you don't follow that, you're gonna screw the blades up. So you really need to take care of these blades. Make sure that you're not overheating them. You'll notice sparks start coming out. Once sparks happen, it's too hot. You need to stop using that blade or you're gonna burn it up. You're just gonna start breaking teeth off. So what Diablo recommends is using these at a low speed to start your cuts and then start getting faster and faster and faster. And if you feel like it's cutting through the material and you still have a long ways to go, back off for a minute. Let the heat dissipate, let it cool down for a little bit, and then start cutting again. They don't specifically recommend that you use any kind of oil or like medium to cut with to keep the teeth cool. But as a general rule of thumb, I think everybody would agree if you put some kind of oil on what you're cutting, if it's really thick, especially if you're doing stainless or anything, if you're trying to drill through really thick material like that, to save your blade, add liquid to it and don't go so damn fast. It's really like every electrician wants to go grab their Sawzall and just like cram that trigger and just cut at full speed, but you do end up screwing the blades up. So what I wanted to talk to you about, show you, is these are both the same blade. They're carbide, thin metal, but this one doesn't have any damage to it and this one does. I took about 1 inch to 1.5 inches of this strip of teeth completely off as I was cutting. And the reason for it is what I was cutting was aluminum, and that aluminum gets really hot. And I didn't notice that some of the teeth were already starting to go. I was cutting on something that was wobbling a lot. There was a lot of vibration and a lot of heat. And so it actually broke a portion of that carbide strip completely off. And I was like, what the hell? And so I went and got another blade and started trying to do the same thing. And instead of ripping the entire strip off, it just ripped a bunch of teeth off. But it was brand new blades, and I was like 2 cuts in, 3 cuts in on a brand new blade, so it shouldn't have done that. So first thing I did was call Diablo, and I'm like, hey, what the hell? And I sat and talked to their engineering department, and they're like, dude, it's because you're using them wrong. Like, carbide is specifically meant for really hard stuff. They market it, all of the companies do this, they market, use these blades, they're badass for everything, but you'll notice that they actually put specific materials on them, specific thicknesses, and there's not a lot of education for people out there about making sure that you're not overheating blades and there's not a lot of vibration. So those are really important things. Just wanted to mention that instead of buying only carbide for everything always, I think for thin metal, using bimetal blades is still a really viable option. It's still viable for doing conduit and all of those kinds of things too, but I do think that the thin metal carbide, you're gonna have a better experience cutting conduit if you don't have your hacksaw around, or if you don't have your bandsaw around. Using the thin metal carbide will still give you a whole shitload of cuts on that conduit or on that strut, whereas you're gonna burn these out a lot quicker. But these are also cheaper, these are more expensive, so it's kind of a toss-up either way. There's not really one way to do it for sure. But that's all. Hope you guys got something out of that. Thank you so much for watching. Love you people, and I'll see you in the next one.